Water hyacinth is an invasive plant that is causing environmental issues and health challenges across the global south. Hyacinth blocks the light and oxygen from reaching the lake ecosystem, leading to a loss of fish and native bird species, preventing fishing and navigation. In Ethiopia, Lake Tana, the biggest lake of the country, has been invaded by water hyacinth since the early 2000s. The government, researchers, and local communities are working together to find the most efficient ways of reducing this invasive plant. As part of this collective response, Debre University, located in the north of Ethiopia, and Offgridgas and Fertilizers, a biogas company from Canada, came together to valorize this invasive plant and turn it into biogas and electricity. Biogas is an energy source that can be produced by the fermentation of manure or crop residues or food waste.
In this project, we use the hyacinth as a feedstock to produce biogas by mixing it with manure and water, and feeding this mixture to the existing biogas digesters near the lake. However, for this mixture to produce biogas efficiently, the green plant material must be ground up. In our project, we tested different methods for chopping and grinding, a local onion chopper design, an electric blender, and a grinder pump. But the most promising method was actually the use of a large wooden mortar and pestle, as this is a traditional tool that is available in every household. We recorded the amount of biogas produced over 90 days and found that hyacinth produces roughly 40 liters of biogas per kilogram, in comparison to cow manure, which produces 25 liters of gas per kilogram.
In Ethiopia, most sources of biomass are already under pressure from the many competing demands. For example, food waste and crop residues are used as animal feed, and cow manure is used for a variety of purposes, including construction, fuel, and soil amendment. Whereas there are currently no other competing uses for water hyacinth biomass. This shows the great potential to produce energy from a freely available biomass source. In addition to biomass, the digestion process also produces a byproduct known as bioslurry, which is a very good natural and cheap fertilizer.
We tested the composition of the bioslurry for nitrogen, phosphate, and organic carbon. Compared to chemical fertilizer, the bioslurry is less concentrated, but it provides the complete range of plant macro and micronutrients. In addition, the high pH of the bioslurry can be beneficial for the acid soils found in the region and in most of Ethiopia. Moreover, given the current price of chemical fertilizer, the bioslurry is highly competitive and locally available. Also, biogas can be used to displace petrol in a small engine, such as a generator. Within this project, we worked with local mechanics to convert small generator to run on biogas. This may be the first time such a conversion process has been done in Ethiopia.
This project shows the multiple benefits that can be provided by the digestion of water hyacinth, the biogas, the bioslurry fertilizer, and even electricity. The use of biogas reduces dependence on wood and charcoal, while in turn alleviating deforestation. In addition, there are numerous social and health benefits, such as a reduction in workload for women and better kitchen air quality. All of this while contributing to the fight against water hyacinth propagation.
I